What's up? Need to check the settings. Okay. What's up, everybody? Am I audible and visible? Come on, I just need to know in the live chat if you can hear me, if you can see me properly. Okay, I just need to know in the live chat itself. Okay. All right, people. So what's going on, ladies and gentlemen, boys and girls? This is me, Yawar Manzoor, and I believe everybody is doing great, nice, and absolutely fine. Okay, I hope everything is correct. Okay, I just need to check my Wi-Fi settings. Yeah. Is it fine now? Is it fine now? Is it okay? Am I audible and visible properly now? Can you just hear me and can you just see me? Yes, now. So everybody of you is doing great, nice, and absolutely fine. Come on in the live chat. Okay, that's great. If this is working right now. Okay, so ladies and gentlemen, boys and girls, welcome to JEE English Unacademy. This is me, Yawar Manzoor, and I believe everybody is doing great, nice, and absolutely fine. So we are running this Fury series, okay? And my name is Yawar Manzoor. I'm a JEE Physics expert, and I welcome you to this JEE English Unacademy. Hit the subscribe button right away. If you haven't subscribed yet, just do it as soon as possible, okay? Okay. That's great. Now, listen to me very carefully. So this is my username on Unacademy. You can definitely hit the follow button over there because we come up with the special classes every single time so that, yes. What is that? What is that? So apart from this YouTube platform, we teach on Unacademy's own platform. Over there, you can basically take the Plus subscription as well as you can take the Iconic subscription, okay? Okay, you can take the Plus subscription as well as you can take the Iconic subscription. Now, the point is, what are the benefits you're gonna get in this Plus subscription? For sure, the country's top educators are teaching you inside this Plus, okay? On this Unacademy's platform, you can definitely check it out by downloading the Unacademy app. Check over there who are the educators who teach you every single day, okay? If you take this Plus subscription right now, the offer is going on. I suggest you to take it right away, and you'll be getting live classes every single day. You'll be getting weekly tests, structured courses, unlimited access. See, structured courses, these courses have been designed by the country's top educators who have got like 20 to 30 years of experience. So that's why. And this unlimited access, for example, if there are 100 educators who are teaching you inside Unacademy, you can watch anybody's lecture any damn time. That's what we call the unlimited access. Even you can create your own batches. For example, there are 5 to 10 batches which are running inside Unacademy, and you want to learn from different educators who are inside those batches. You can select your own educator and create your own batch. That's what we call the complete access. Understand? And this weekly test, once you are done with the stuff that you have studied for the entire week, then you can basically go for these weekly tests. Next thing is Iconic subscription. If you take this Iconic subscription, you're gonna be getting all the benefits you get in Plus, and some of the extra benefits, like you have personal guidance, means there will be the personal mentorship, okay? Personal mentorship will be over there. He'll be guiding you personally. Understand? A personal mentor will be given to you. If you need any sort of clarifications, you have any sort of doubts, you can definitely ask him. He will be guiding you how to basically overcome this stress. He will give you the strategies. Any sort of doubt, you can definitely ask him. And this test analysis, once you are done with your test, afterwards you will have to analyze your scores, in what portion you are lagging in what portion you have to work more, so that in the upcoming test you will get the good scores as compared to the previous test. That's what we call the test analysis, and this is definitely done from our end only. Our educators will be basically doing this, okay? No. Who? When? I don't exactly remember. Who are you talking about? I didn't do anything. There were a lot of people who were live yesterday, huh? I don't know what you're talking about. पता नहीं यार. And this is the experts guidelines. अब थोड़ा सा भी. Okay. When will we complete the course? By next 2 months for sure, okay? We're going to be completing the entire course. Yesterday, friction lecture. I didn't do anything. Even all the people who were giving the wrong answers, I told them, why are you giving the wrong answer if I have cleared everything in detail? तो मैं सबको बोला हूँ. I told that everybody, to everybody, not just to that one guy you were talking about. I am really sorry अगर उसको बुरा लगा है, okay? I'm really sorry from the bottom of my heart. I don't know, seriously. Okay. And this study material, tell him to message me, please tell him to message me on Unacademy or on my Instagram, Unacademy, whatever, wherever he can, or Telegram, he can definitely message me. I'll definitely talk to him. I need to talk to him. Okay. Oh, so this is the study material that you're going to be getting in this plus subscription, in this iconic subscription that will be sent to your doorstep. This have been designed by the top educators of the country and these study planners as well. And you can take this plus subscription for, you can take this subscription for 3 months, 6 months, 12 months, 18 months, and 24 months. Okay. The EMI options are available as well. If you take this subscription, these subscriptions, it's not like you have to pay the entire amount at once. You can pay it every single month. Right now, the discount is going on. I suggest you to basically use this code in order to get the maximum possible discount. Go for this as soon as possible. So this is my code. Go for this as soon as possible. Next thing is, you can take this iconic subscription for 12 months, for 18 months, for 24 months. You can use my code in order to get the maximum possible discount. Okay, I'll just tell you what are the discounts that are going on. Before that, let me tell you, these are the batches which we have launched recently, not recently, yesterday itself, like 22, 22, 22, 22, and this is 29. This is the Junoon JEE Unacademy JEE educators are teaching you inside this batch, and definitely the country's top educators are teaching you inside this batch. Okay, so I want you people to basically join any of these batches if you want to take your rank to the next level. So for sure, you should definitely go for this one, okay? Yeah. Please tell that guy to message me on my Telegram for sure, okay? It's very necessary. I need to talk to that guy. Okay, and this prices will rise for sure. I suggest you to basically use this code, okay? Use this code. If you use this code, you will definitely get the maximum possible discount. Now, this is the before price hike. This is the after price hike. So these are the prices. You can definitely check it out. And this is the after price hike for 24 months, 12 months, 6 months, and 3 months. Next is, we have this mega combo IIT JEE plus CBSE. You can definitely save up to 20,000 in this one. If you take this plus subscription for 12 months, you'll be getting 15% plus 10% off. If you take it for 24 months, you will be getting 20% plus 10% off. How exactly? By using this code only. If you're looking for taking Unacademy's plus our iconic subscription, take this now only. Understand? Next is, now see, ladies and gentlemen, boys and girls, the point is, like few days back, there was a guy who was asking me, sir, I want to learn free on Unacademy. Is there any way I can learn free on Unacademy? Yes. So this is the way. You should definitely go for this Unacademy Combat. If you take this scholarship, if you basically go for this scholarship test, if you get the rank from 1 to 3, you'll be getting 100% of scholarship. Okay. If you get the rank from 4 to 10, you'll be getting 75% of scholarship. What you are supposed to do in this, you have to give a test on 26th of September. The link is in the description below. Okay. Check that link out. And it will ask for a code. You need to use this code while you enroll in this one. This is completely for free. You don't have to pay anything. Just go with this one. And this is the IIT JEE Mega Combat. Understand? Even you can win up to 4 crore plus scholarship. If you don't want this much of money, at least get the free subscription from Unacademy. So go for this test as soon as possible. Fine. Now we have this beautiful feature on Unacademy, that's ask a doubt. If you have any sort of doubt, you can definitely ask it, and you can ask unlimited number of doubts. You can ask the doubt anytime. You'll get the high quality solutions for sure. There is a doubts and solution option on Unacademy app. Choose a picture, okay, upload it on Unacademy. Make sure that should not be blurred, it should be very clear, and crop that particular doubt. It's not like you'll send 10 or 15 doubts in just one single picture. No. So you'll get the doubt within no time for sure. These are the do's and don'ts you need to keep in your mind while you go for this one. So ladies and gentlemen, boys and girls, we will be talking about that's the Kirchhoffs. How do we pronunciate it? Okay, Kirchhoffs law. Okay, these laws. Okay, I'll just write laws. We need to basically talk about these laws. Exactly what are these laws? You might have studied this in your 10th class. Okay, these are very basic laws, very easy laws. You can definitely kill it. You can definitely kill every damn question in this one. Now the first thing is, why do we study these laws? What is the application of these laws? That's what we're going to be talking about in this one itself. Fine. If I ask you to tell me if there is a circuit given over here, forget about this. This is a complicated circuit. This is also the complicated circuit. If I ask you the simple question, could you please tell me if there is a circuit given, understand, in that circuit, could you please tell me how much is the potential, how much is the current flowing, how much is the potential difference? If yes, sir, it is very simple. We'll use the Ohm's law and we'll get the potential, current, whatever it is, those basic simple concepts that we have studied previously. Fine. Now, if I give you some circuit which is something like this, is a complicated circuit, okay? If I ask you to tell me the current flowing over here, how can you exactly find that? If I ask you to tell me the potential, how can you exactly find that? So that's why we use basically these laws in order to solve these complicated circuits, in order to find the current in these complicated circuits. I'll show you in the examples afterwards, okay? I'll tell you, we'll have to study this in future, okay? Don't worry, Phil. For now, just focus on whatever I say. Okay, so we'll have to basically find this current, potential that we're going to be talking about in this one only. Now listen to me very carefully. If I say for example in this case, if I say for example, we use basically these laws in order to find, in order to solve complicated circuits, okay, or to find potential current, whatever it is. Fine. So we're gonna be basically using these laws in that case. Now if we talk about this circuit over here, we say basically this is the resistance. We represent this resistance basically like this. This is the symbol of resistance. Understand? This is the resistance. I have told you previously what is the resistance in the last lecture itself. Resistivity, resistance. Resistance is nothing but it is something which opposes the current. Understand? It opposes the flow of current. So that is what we call the resistance. The symbol of this resistance is basically this. We represent this resistance in circuit something like this. Understand? The next thing is, this is how we exactly represent the battery. This we have studied previously also in capacitors and all. So this is how we exactly represent the battery. Positive terminal, negative terminal. What is the work of a battery? That we have studied previously. Battery doesn't supply the charge. But what exactly battery does? Battery is basically taking the charge from one of, if we talk from the capacitor's point of view, battery is basically taking the charge from one of its plates and taking it to the other plate. So over here, it will do the same thing. It will basically it will be a reason for flow of electrons over here, flow of charge over here. So basically this will do the external work done so that the electrons will flow in this one, so that the charge will flow in this circuit. But this will not provide the charge. This will not supply the charge. This will do the work done. This will supply the energy. So we'll use that energy in order to basically what? For moving of electrons, for motion of electrons in a circuit. That's what is the work of a battery that we have studied previously in detail. Exactly. Understand? So this was all about this one. Now let's move on to the next thing. So first of all, let's talk about this junction. Everybody is understanding this one? Fine. So let's talk about this junction. What this junction is all about, we need to basically see this one. Now see, this junction, it's a point in a circuit where three or more conductors meet, also called nodes or branch, okay, branch points. Now see, if I say this is a circuit over here, fine, can we take this point? If I talk about this point, how many conductors are exactly meeting? You, for example, you understand, you take these as conductors. Wires, 3 different wires are meeting at a point. So if we talk about this point D, so over here, this is the first one, this is the second one, this is the third one. So can I say this D is exactly in this circuit, this D is exactly branch, this is what we call the, kya tha naam iska, junction, okay? This is what we call the junction over here. Can we say this C is exactly the junction 100%, okay? This C is exactly the junction. We just have to solve the problems in this one. That's all. Okay. So this is what we call the junction. This is what we call the junction in this case, where 2 or 3 conductors exactly meet through 2 or 3 wires, not 2, 3 or more than 3 wires exactly meet at that point. That's what we call the basically junction. And what is this loop? Loop is what? Any closed conducting path. Over here, can you please tell me what is the loop? In this case, can I say over here, this is the loop over here? Can I say this is the loop over here? Clearly, I can definitely say this is the loop over here. Any closed conducting path, we say basically that is nothing but loop over here. Fine. Everybody understanding this one? I hope all of you. Okay. So, come on, in the live chat. Getting me? So this is nothing but junction. This is nothing but junction. And this is but nothing but loop. This is a conducting loop. Okay, this one and this one exactly. A, B, C, D, A. A, B, C, D, A, exactly the loop over here. Okay, this is a closed loop. And this is also the closed loop over here. Now, let's move on to the next thing that we need to exactly discuss in this one. Okay, everything is clear. Fine. Now, what is this Kirchhoff's first law, or we say Kirchhoff's current law, or the junction rule? Understand? These are the names, okay? Nothing. It is very simple, very basic. We don't have to do nothing in this one, just we have to understand this. Now see, in simple language, if I say, for example, there is a current that is coming something like this. Understand? This is I2 coming something like this, okay? This is a point over here. So this is I1 entering this point. This is I2 entering this point. And what are the currents leaving this point? You will say, sir, this current is leaving this point. See, this is in the outward direction. This I3, this I4 is in leaving the point. Fine. I'm saying in simple words that, sir, this current I1 and this current I2, this current entering the point, the number of currents or the total current entering the point will be equal to the total current leaving that junction, that point exactly. Understand? This is nothing but Kirchhoff's law. Understand? The sum of all the currents entering a point is equal to the sum of currents leaving the point. The number of currents, if this is the current entering this point, this is the current entering this point, what are the currents leaving? You will say, sir, this one, this, sir. So simply all of those currents, add all of those currents, sum of all those currents which are entering this point will be equal to the sum of all those currents which are leaving the point. We can define it like this also. The amount of charge per unit time, that is what we call the current. So the charge per unit time entering this point will be equal to the charge leaving per unit time in this case. Understand? Per unit time, charge leaving per unit time leaving this point. Understand? This is a very simple law, very basic law. That's what exactly over here. So it is saying that the algebraic sum of currents into any junction is basically 0. If I say, for example, at this point, can I say it from this? I can definitely write this is I1 plus this I2 minus I3 plus minus I4. This minus I4, this minus I4 will be equal to 0, 100%. So can I say this net of all at this junction? I would say at this junction will be equal to 0. That's what exactly this is saying. Understand? The amount of current entering in this one will be equal to the amount of current leaving this one. Okay? Okay. That's why I told you I need to talk to that guy. Okay. I exactly don't remember. I just have to watch that yesterday's lecture where exactly I basically told him something that you're talking about. So that's what I'm saying. So tell him to talk to me, please. Okay. Or just you text me on my Telegram. I'll text him from here only. Okay. So this is what we call the Kirchhoff's current law or the junction rule exactly. Understand? There is nothing more in this one. There is nothing more in this one. It is basically based on the conservation of charge. Understand? We say the amount of charge per unit time entering this point will be equal to the amount of charge leaving this point. That's all. Because current is what? Charge per unit time. Charge per unit time. How much charge is basically entering per unit time will be equal to the how much charge is leaving per unit time. That's what we called over here. Exactly. That's why we say law, it's based on conservation of charge. Understand? I hope this is clear now. Let's move on to sign conventions. These are very important. I want you people to basically remember all of these sign conventions. Okay, this we will be using in our upcoming questions. Listen to me very carefully. If I say, for example, potential drop, if I say, for example, this is a positive terminal, this is a negative terminal of a battery. Okay, you are moving, for example, like this. You will say, sir, what is this moving like this? I'll show you this in the questions. For now, you just remember whatever I say. Okay, just keep this in your mind. If I say this is the point A and this is the point B, fine. Am I going too fast? Come on, in the live chat. So this is the point A exactly, and this is the point B exactly. So I'm saying that I'm traveling from this point A to point, not traveling. So basically, I am supposed to go from this point A. When we basically take it over the circuit now, so then I'll tell you over there, go from in this direction, go from A to this, complete this circuit in a closed loop. So that's what exactly it means. I'll tell you after some time. It will be basic. It will get clear to you over there. So for now, you just remember, if you go from positive terminal to negative terminal, you take this as what? This is what we call the from higher potential to lower potential. That is what we call the potential drop. Understand, this is drop in potential. If you go from this positive terminal to negative terminal in this direction, so we say this is potential drop, and you take this potential drop as nothing but you take this as positive. Understand? This is what I'm saying exactly. And a little fast. Okay, I'll just decrease my speed. Listen to me very carefully. These are the sign conventions, okay? I'm saying if this is a positive terminal, this is a negative terminal. You go from this A to B. Understand, this is your direction. Fine. You take this potential, this is a potential drop because you are going from higher potential to lower potential. Fine. So what is that? That's drop in potential. That's take drop in potential as positive. So you take this potential exactly as positive, potential difference, potential positive. Understand? Now, from A to B, you are moving. You are moving from lower potential to higher potential. This is gain in potential. Understand? When this happens exactly, so you take this as negative. Understand? Because you take drop in potential as positive, you take this drop in potential as negative. 100% fine. Third point exactly is, now when we talk in case of the resistors, there is something different. Listen to me very carefully. This will confuse you if you don't listen to me properly. See, I would say over here, when you go from A to B, in this case, so we say current is flowing in this direction. You are saying, now you will ask me, sir, in this case, what is the current? See, in case of this battery, the current doesn't matter. The direction of current doesn't matter. Over here, you just have to basically focus on what? I'll tell you after some time this. Over here, you just have to focus on the current. If current is going from this point to this point in this direction, current flows from higher potential to lower potential. We say in this case, if the direction of the current is like this, means electrons are flowing in this direction, opposite to this one. You might have studied this when we had the first lecture of current electricity. So can I say if electrons are flowing in this direction, means electric field is set up in this direction. Understand? If electric field is set up in this direction, obviously the current, the force on electrons is in the opposite direction. So electric field is in this direction. You tell me one thing. We say potential drops in the direction of electric field. You might have studied this previously. Potential drops in the direction of electric field. How? See, if I say what is the formula for potential, if I say, for example, this is a Q, okay, as what is the direction of electric field, you will say, sir, this one, okay. If I say how much, what is the potential at this one, you will say, sir, KQ by R. If you increase that, it will decrease. Potential will exactly decrease. So potential, what is the direction of electric field? This one. So if you keep on going in this direction, so potential will exactly decrease. We have studied this previously. Okay. Just remember, potential decreases. Understand? We say potential is KQ by R. V is equal KQ by R. Understand? At this point, the potential, if this is a charge Q, at this point, this is away from this one. If the electric field is in this direction, if you increase this one, the potential will exactly decrease. So we say potential decreases in the direction of electric field. So we say this potential decreases in the direction of electric field. Fine. If this potential decreases in the direction of electric field, means this is what we call the drop in potential. We take drop in potential as positive, so that's why we are taking this V is equal to IR. Why IR? Because current is I and resistance of this is, I would say, R. That's why I'm taking this as IR. Okay, over here it was battery, that's why simply, okay, E, take it E. So in this case, what will happen? Just the reverse of this one. So we say in this case, the current is flowing in this direction. So what is this? This will be drop in potential, just the opposite of this one. So this will be V is equal to negative of IR. Negative of IR. Okay, fine. Negative of IR. Okay. Yeah, you can think it like that way also. From this point to this point. Okay, I gave you the clear explanation. Just go according to that only. Understand? Because you have, whenever you basically have to find this one, what is happening with the potential in this case, you basically take the direction of current. Over here, you don't take the direction in which direction you are going. No. Over here, in case of this battery, you take that direction in which you are going. Direction of current doesn't matter over here, but here direction of current matters. So that's why in case of resistors, so that's why I'm saying that in this case, from positive to negative, this case is happening over here. Now see, next is, in case of the battery over here, as I told you, from negative to positive, this is what gain in potential we take it. If I say, for example, this is E, understand? So this is nothing but E. Battery, we represent this with E, okay? So this is what, nothing but we say negative E. Same is the case over here. So see, direction is what? In this direction, direction of current, I would say this is the direction of current. Direction of current doesn't matter. This matters, in which direction you are basically moving from A to B, so we take it negative. From over here, lower potential to higher potential, we take it negative. Direction of the current in this one, okay? Fine, just remember all of these sign conventions. This is the next one. In this case, so we take basically E. What happens over here? We say this is drop in potential over here. We take drop in potential as positive. We take drop in potential as positive. किधर गया यार? We take drop in potential as positive, that's why plus E because of this one. And in this case, we take this as negative R because this is in the opposite direction. Clearly, you can see it from here. This is in the opposite direction, negative of R, IR. Fine. Simply, you can definitely match all of those with this one and you will get the clear understanding of all these. Understand? Same is the case over here. This is just the opposite. This is gain in potential, negative. And this will be also negative in this case. So in this case, it will be positive and this will be positive. Drop in potential, and the direction of this current is also from this point to this point. So this is the direction of current in this case. This is the direction of current. This is the direction of current. We say this is E plus this IR. Understand? I hope there is no confusion in your mind. Just remember the first four, okay? Then rest of the other sign conventions, you can basically do it with your mind only. So this happens over here in this case exactly. Fine. The drop in potential, and this is IR exactly. Fine. Now let's move on to basically the questions. Come on. I want you people to basically solve this question and tell me what is the value of this I3 and what is the value of this I4. Okay. Come on. Tell me. See. Can we say over here, what is the junction? I call this point A and I call this junction B exactly. What is the KCL saying? Simply, this is the current, Kirchhoff's current law. What does it say? The current, the sum of all the currents entering the point will be equal to the sum of currents leaving the point. Understand that junction? Fine, junction rule. Same, use it over here. If I say, for example, this is the I1 entering this point, this is the point A. Can I say this is the junction A? And this is exactly the junction B. I can definitely say it over here, okay? So what is the current entering this junction A? You will say, sir, this 2A is current. 2A is basically entering this junction A. So, and what is the current leaving this junction A? You will say, sir, this 4A and this I3. I1 is entering, this and this are leaving. So can I say apply? So, listen to me. So apply KCL on A. So can I just write in that case, this I1, it is the current entering this point A, will be equal to them, sum of all the currents which are entering the junction will be equal to sum of all the currents which are leaving the junction. Which are the currents leaving the junction? This one and this one. You'll simply say, sir, that is I3 plus and this I2 exactly. So how much is I1? You will say, sir, this is nothing but 2 exactly. How much is I3? I3 we are supposed to calculate, plus how much is I2? You will say, sir, this is 4. You take it over there. So can I say this I3 is nothing but, it will be -2 only. So we got this I3 as -2. Fine. Now the point over here is, what is this negative sign indicating? Negative sign is indicating that the direction of I3 which is mentioned in the diagram is not correct. So it has to be opposite to that. That's why this is 2 and this is 2. Out is coming as 4. That's why this is not in this direction. Negative sign is basically telling us the direction of current is exactly wrong over here. So fine, done with this one. Next one, we'll move on to this one. Listen to me very carefully. Now, take this point exactly. Fine, apply KCL at B. Okay, at this point. You will say, what are the currents entering this point? You will say, sir, this one I3 and this I5 according to the diagram we'll take. So this will say I3 and this plus I5 exactly will be equal to this I4, because this I4 is exactly leaving. Understand? These are the currents entering and this is exactly leaving. How much is this I3? You will say, sir, this I3 is nothing but that is -2. Plus, how much is this I5? You will say, sir, this I5 is nothing but 3 is equal to that's nothing but I4. So I4 is coming out to be 1 only. So the direction of current over here is correct. Fine. Okay. Let's go on to the next one. Come on, solve this question as soon as possible. I want all of you to solve this question. Come on. Everybody understood the theory till here? This current KCL. So whatever the theory I told you, this, remember the sign conventions. Second thing is, remember this KCL. Okay, that's all. So what is this KCL? The sum of all the currents which are entering a point, entering a junction, will be equal to, must be equal to the sum of all the currents which are leaving the junction. It is simply what according to the one, this is negative, so it means it's like this, leaving, entering, that doesn't matter. Okay, don't think it like that way. The way I am telling you, just keep this in your mind, that's all. Because so this negative positive sign indicates over here the direction of this, whatever we have taken the direction in diagram, that is correct. So now I want you people to basically solve this one. I want you people to solve this one as soon as possible. Now listen to me very carefully in this case. Okay, listen to me very carefully in this case. So we say, if we solve this question over here, this is a very simple question, not that difficult. Okay, what is the option in this one? A, B, C, D. A, B, C, D. Come on, all of you, mark the options. We are supposed to find the current through 12 ohm resistor. This, we are supposed to find the current through this one. This I, we are supposed to exactly calculate. How can we exactly calculate this one? Let me just tell you. We'll say, for example, this is the point exactly over here. Okay, can we say this is a junction? Apply the KCL at this point and you will get this solution. Apply the KCL at this point and you will get the solution for sure. Okay, if we say, for example, this is the point A, what is the first thing that we do? We apply KCL at point A. Understand? We apply the KCL at point A. Listen to me very carefully. We apply the KCL at this point A. Fine. When we are applying this KCL at this point A, so means the number of currents, sum of all the currents entering this point will be equal to sum of all the currents which are leaving this point. Is it correct? Okay. So can I say, what are the currents? What are the currents which are entering this point? I would say simply that is nothing but this I. Okay. What are the currents that are leaving this one? You will say, sir, that is nothing but only I is entering this one. What are the currents which are leaving this point? That is this one, that is this one, that is this one. You will say, sir, that is this I1 plus this I2 plus this I3. Can I definitely write it like that? 100%, 110%. Now, can we write this I in terms of V by R? 100%. Because we have studied previously, V is equal to IR, this relation. Understand? We have studied this relation in detail previously. I hope you remember this one. Okay, V is equal to IR. अरे यार ऐसे मजा नहीं आता लिखने में. IR, ठीक है ना? So what is this? Potential proportional to this current. Previously, we have discussed this in very detail. So could you please tell me in this case, how much will be the resistance? How can you exactly find this resistance in this case? You'll say, sir, simply in this case, I would say, okay, current in this case, I write that is V by R. Okay, fine. Now, over here, why are we basically doing this stuff? Because we know over here what is the potential drop or what is the potential difference over here and how much is this resistance R, how much is this resistance R. Fine. Now, can you just tell me in this case, instead of this I, can I just write V by R? 100%. Now, as the current is flowing in this direction, so I can say that current flows from higher potential to lower potential. So I am assuming that at this point, if I say, for example, potential is V, for now you consider the potential at this point is V, because we are supposed to find this potential only, then only we can find the current through this one. Even we can find current through this one, through this one, through this one. Fine. So can you tell me how much is the potential over here? You will say, sir, 15 minus this V exactly, from higher potential to lower potential. You will say, sir, that is this in case of this V by R. Instead of this, I will just write this is 15 minus this V, 15 minus V upon what is the R? That is simply over here, this 12 exactly, because R is 12. Resistance in this case is basically 12. I can definitely write it like that. Fine, will be equal to, if I write this I1, if I write this I1, this is higher potential, this is lower potential, because the direction of the current is this one. I told you previously, if the direction of the current is this one, means electric field is in this direction. Understand? So if the electric field is in this direction, so potential decreases in the direction of electric field. So potential decreases from this point to this point. So potential will decrease in this direction. So in that case, this is at higher potential, this is at lower potential. That's why I'm writing V minus this V. Okay, why is electric field in this direction? Because electrons are flowing in this direction, so the current is in this direction. So if the current is in this direction, so we say electric field is in this direction. Or if the electrons are basically being pulled in this direction, so it means electric field is opposite to that. We have studied this in electrostatics 100 times, this in very detail. So can I just say, in case this I1, we can definitely write this V minus this 2 exactly, V minus this 2 upon how much this will be, this V minus this 2, and this will be exactly 6 over here. Can I just write it like that? And this will be plus, what is I2? I2 is nothing but that is V minus this 8, V minus this 4, this V minus this 4 upon how much is the resistance? You will say, sir, that is 8. And then plus, what is I3? I3 is this one. You will say, sir, this V minus this 3 upon, you will say, sir, how much is this? This is what we call the 4. Fine. Everybody understood this one? Come on, in the live chat, give me some signal, okay? So we say, if you solve this one, this will come out to be exactly 68 by 15. Okay, so we say this is nothing but V will come out to be, that is nothing but 68 by this 15 exactly. Okay, we were supposed to find this V only, so we got the value of this V. So V came out to be how much? That is nothing but 68 by 15 exactly. So when we got the value of this V, fine, now we can find the current through this one. How? Using this only, na. V is equal to IR, or directly take this part. We are supposed to find the current through this one. Even we can find the current through this one also. Current through this one, current through this one, current through this one. I'm asking you to find the current through this one only. You will say, sir, that is nothing but current through this one is nothing but, we basically represented the current through this with I. So I we represented 15 minus V upon 12. So can I say this I will be nothing but, this I will be nothing but, that is 15 minus V upon this 12 exactly. 15 minus V upon this 12 exactly. So this is 15 minus V upon this 12 exactly. 15 minus V upon this 12 exactly. What is the value of this V? If V is equal to IR, I am using current. Find the current through this resistor. You will say, sir, V is equal to IR. I is equal to V by R. So how much is V? 15 minus this V. So what is the value of this V? We got this. That is 68 by 15. So you'll just say 15 minus 68 by this 15 upon this 12 exactly. Everybody understanding this one? Come on, man. Very simple, not that difficult. Okay. So we say this I will come out to be, that is how much? 157 by 180 ampere exactly. Everybody? Okay. So this is the current through this one. Same. If you want to find a current through this this 6 ohm resistor, what will you exactly do? You will take this one, V minus 2, that is 68 by 15 minus 2 by 6, that will be current through this one. Same, if you want to find the current through this one, that is 68 by 15 minus 4 by 8, that's current through this one. Understand, that will be I2. Okay. Yeah. Come on. Next one. I want you people to go for this one as soon as possible, because I told you, I have already told you what is the basically rule, what is the approach that you can exactly go for solving this type of question. Come on. As soon as possible, go for this one, solve this as soon as possible. Do let me know what is the answer in the live chat. Here, you are supposed to find the current in every branch. 1, 2, 3. Find the current in every branch. These are the JEE mains level questions, okay? So if you solve these questions, for sure, you can solve any of the JEE mains level question, for sure, 100%, okay? Because this is the JEE mains level material only. And like this video, like the lecture, find the current through this one, okay? For example, you take this as a junction over here, you mark this as a junction, understand? You say, for example, this is nothing but X. And now you take this one, current through this one, current through this one, current through this one. Apply the KCL at X. What is the first thing you do? You'll say, sir, apply KCL at X. When you apply the KCL at X, what is the next thing that you are supposed to do exactly? What is the next thing you are supposed to do? You'll say, sir, the algebraic sum of all the currents at this is exactly 0. Understand? So can we say, either we say the sum of the currents entering this one or leaving, or we say the sum of all the algebraic sum of all the currents entering a junction is equal to 0. So can I say I1 plus I2 plus I3 in that case will be 0. Understand? You mark the currents over here. I2, I1 plus I2 plus I3 is equal to 0. Fine. We can definitely use this one. Now, find the current. We can definitely write this current in terms of V by R over here. We can definitely write it like that. Now, can you tell me over here how much will be this I1? You'll say, sir, this I1 will be, what is the potential over here? This is exactly at higher potential. Understand? So the current is exactly flowing like this. So we say this X minus 5 by 2. V by R. Resistance is exactly R. So instead of this, can I just write this is X minus this 5 upon this 2 exactly over here. Fine. I can definitely write it like this. Then plus I2. Instead of this I2, what I'll just write, that is X minus this 10. That is this X minus this 10 upon what is the resistance, that is 2. Plus what is the value of this I3? You'll say, sir, X minus higher potential, lower potential. X minus 20. X minus 20 by this 2 exactly will be equal to 0. Okay. Great, great. Come on, solve this one as soon as possible. Solve this as soon as possible. Now you need to find the value of this X over here. I guess this will come out to be 3X is equal to 35. You just solve it, okay? We don't have that much of time over here because I need to show more and more questions. I don't have to solve the 8th class mathematics. So this will be equal to, that is nothing but 35. So I can say this is nothing but this 35 by 3 exactly. So we got the value of X as 35 by 3. Now I am asking you to tell me this current I1, because through this branch, through this branch, through this branch, how much will be that? If I say this is A, this is B, this is X, and this is C, through this branch, through this branch, through this branch, you will say, sir, that is nothing but if we are supposed to find this I1, that is nothing but this V by R. So that is nothing but X by 5 by 2. What is X by 5? That is this 35 by 3 by 5 by this 2 exactly. Similarly, find this I2 will come out to be, that is 35. Do the calculations by yourself. If there is any mistake in calculations, just do this by yourself itself, okay? Yeah. Come on. Okay, so we say 35 by 5 minus, kidhar gaya ye? 35 by 5 minus this 10 upon this 2. Similarly, I3 we can calculate over here, that is this 35 by 5, 35 by 3, 3 minus 20 by 2 exactly. You'll get the values. Okay, so this is how we exactly solve these type of questions. Do let me know the answer of all this I1, I2 and I3. And let's go for the next one. Come on, solve this question right here. Okay, there are two branches right now. Okay, there are two junctions exactly. So this is the first junction, I would say. I call this as X, and this is the next junction. I call this as Y. Come on, here will be two equations. Here two equations will be made. You are supposed to solve this one. Okay. Come on. Solve this as soon as possible. Okay. Getting me? Two junctions are over here. So there will be two equations will be formed over there. Fine. So first of all, you need to apply. What is the first thing that we do? Apply. We say first thing, apply KCL at X. At X. We are applying the KCL at this X. Fine. So when we apply this KCL at this X, what we will exactly do? You will say, for example, in this case, first of all, let's draw the currents over here. Let's draw the currents exactly. So you will say, sir, in this direction, if I say, for example, I1, in this direction, I would, for example, say I2. In this direction, I would say, for example, I3. Okay, this is I3. And I would say at this point, for example, over here, this is I4, and this is I5, and this is exactly I6 exactly. Okay, you'll solve this. You'll get to know. See, make sure if, for example, the current is coming out to be negative in any case, so it means that the direction you took the current, the direction of current you took initially, that is wrong. Understand? So reverse that direction. That's why, that's what the negative side indicates over there. That's why. Make sure. Okay, these are the directions we are taking according to ourselves only. But what is coming out to be the answer, that will give us the exact direction of the current. If that is coming out to be positive, then the direction we took is correct. If that is coming out to be negative, then the direction we took is wrong. Fine. Now listen to me very carefully. So we say apply KCL at X. Fine. We are applying the KCL at this X. So can I say, in that case, the sum of algebraic currents at a junction will be equal to 0. So in that case, I would say this I1 plus this I2 plus this I3 will be equal to 0 only. Can I say it like that? 100% I can definitely say it like that. I1 plus I2 plus I3 will be equal to 0 in that case. 100%, 110% sure? Yes. Done. So now, can you just write this in terms of this I is equal to V by R? 100% we can write this in terms of this one also. So can you just tell me this I1, we can just write, this is at the higher potential, this is the direction of current. So this X minus 4, can I just write, this is X minus 4, that's V, understand? So upon, how much is the resistance? You will say, sir, this is 2. Plus, in case of this, you'll say, sir, X minus 2. X minus 4, yeah, X minus 2 in this case. So, sir, this X minus 2 upon, what is this resistance? You will say, sir, that is nothing but 2. Everybody understanding this one? Come on. So this is 2 and plus in this case I3. You'll say, sir, this is I3. Direction of I3 is like this. If direction of I3 is like this, that means X, this is at higher potential, this is at lower potential. X minus Y in that case. So it will be X minus Y upon the resistor over there. That is nothing but 2. It will come out to be 0. Fine. Solve this equation. Do let me know what is that. So it will be 3x minus y is equal to 6 only. Understand? If you solve this equation exactly, 3x minus y is equal to 6 only. So once you get this equation, call this as equation number 1. Fine. Now take this second one. Apply KCL at y. The next thing. At this junction, we are applying the KCL. Now, if you apply the KCL at the next junction, so what you're going to be exactly saying that, see, first of all, how many currents are leaving? You will say, sir, I4 plus this I5 plus I6 will be equal to 0. Okay, sum of all the algebraic currents at a junction will be exactly equal to 0. So in that case, I4, can I say this is I4, this is I5, and this is I6? Can you write this I in terms of this 100%. So I4 will be how much? You'll say, sir, if I4, the direction of I4 in case of resistor is this, means this is at higher potential, this is at lower potential. So this will be y minus x. Y minus x upon, this is y minus x upon, resistor is nothing but that is 2. Plus, okay, plus, what is I5? You will say that's y minus 2 upon 2. That is y minus 2 upon this 2 exactly. Fine. And then we have this. Okay, there is resistor only, and this will say y by 2 exactly. This is plus, this is y upon this 2 is equal to 0. Is equal to 0. Fine. Everybody understood this one? Everybody understood this one? I hope so. Okay. So we can definitely write. Fine. 3y minus x is equal to 2. This will be the equation number 2. Okay. After solving, now when you solve this equation, okay. So when you solve this equation, linear equation in 2 variables. When you solve this equation, you will get the value of x is equal to 5 by 2 and y is equal to 3 by 2. X is equal to what? That is 5 by 2. The potential at this point, y is equal to, that is nothing but 3 by 2. Fine. So you got this and this. Fine. You got the potential at this point. You got the potential at this point. This you were exactly supposed to follow in this case. So when you got the potential at this point, now can you find the I1? Can you find the I2? Can you find the current through all these what branches? So that is I1, I2, I3, I4, I5, I6. Can you find all of these currents? Which one? See, listen to me very carefully. We got this equation, fine. By solving this equation, we are getting this equation. Understand, this is the 3x minus y is equal to 6. First equation. This is the second equation that we are getting from this one. Next equation. So, after solving this equation and this equation, we got the value of x only. Hey, isko solve karke aata hai na, 8th class mein padha hai na. So we got the value of this x, we got the value of this y. What is x and y? X and y, we took the potential initially at this point. Y is the potential at this point, at this junction. We assumed that. So what is that? 5 by 2, 3 by 2 volts. Okay. So we got the potential over here, we got the potential over here. Now the point exactly at this point is when we got the potential at this point, we can find the current I1, I2, I3, just as we did it. KCL at Y. This I4, we are saying that this I4 is in this direction. If we take, for example, this, we are taking this as a junction over here. The currents which are leaving, this over here, what do we say? Kya naam hai iska? This is branch over here which is connecting with this one. Consider this, forget about this junction, understand, forget about the other junction. You consider this junction. So in this direction we say I5, we are assuming these as a directions, okay? The direction of currents. I told you, once you get the value of all these I1, I2, I2, if that comes out to be negative, means the direction you took, that is wrong. Understand? These are the arbitrary directions we are taking right now. Arey yaar, that's why I am saying when you are considering this I3, so forget about this one, na. When you are considering this I3, what is the potential between this and this? You will say, sir, X and this is Y. So if I3 is exactly flowing from this point to this point, so this current, forget about I4. Don't talk about the I4 right now. I4 may come out to be negative at the end. Understand? So then that means we took the I4 as a wrong direction. These are the arbitrary directions that we are taking right now. Okay. Arey yaar. Listen to me very carefully. Consider this as the junction 1. Fine. You say in this, these are the arbitrary directions. These are not given in the question. So we are taking, I am assuming that I1 is in this direction, I2 is in this direction, I3 is in this direction. Okay, done. So this is exactly happening the scene over here. We calculated the this equation. We got the equation from this one. You will say, you are saying, sir, if this I1 is basically flowing like this, you are saying, sir, how is I1 flowing like this? It can be like this also. Yes. So that's why I am saying in this first equation itself, yahan pe यहाँ पे we got the value of current as I3. What we assumed? We assumed the direction of current is what is actually, it is like this. That's why it came out to be negative. These are the arbitrary directions we are assuming. That's why it can come out to be negative at the end. That means we took the direction as a wrong, so then correct it at the end. This is how we exactly approach the question. Now you getting me? You getting me? Now when you basically took this junction, forget about this junction, there is this current coming in this side. You'll say, sir, this current is also in this direction, this current, what's happening over here? Arbitrary directions. At the end, once you solve this, it may come out to be negative. Then accordingly you fix all the directions, then accordingly you fix the directions of all these. Fine. Come on, you got it now? Now listen to me very carefully. If I say I need to calculate this I1, you will say, sir, I1 is what? X minus 4 by 2. So you will say, sir, this I1 is nothing but X minus 4 by 2 exactly. Sir, this I2 is what? You'll say, sir, this I2 is X minus 2 by 2. That is X minus 2 by 2 exactly. Sir, what is this I3 exactly? You'll say, sir, this I3 is nothing but X minus Y by 2. That is X minus Y by 2 exactly. Just put the value. What is the value of this one? That's 5 by 2. You'll say, sir, 5 by 2 minus 4 by 2. Calculate this one. This will be 5 by 2 minus 2 upon 2. Calculate this one. You'll say, sir, 5 by 2 minus, what is the value of Y? What is the value at, what is the potential at Y? That is 3 by 2 minus by 2. Find this one. Similarly, you find this I4, you find this I5. Similarly, you find this I6. Check how much this is coming out to be exactly. Fine. When you are considering this, okay, forget about this. When you are considering this I4 over here, when you are considering this I4 over here, okay, when you are considering this I4 over here, that means the current is flowing in this direction in that case, okay, I4. So means higher potential to lower potential, okay, in case of resistors, explained already. Electric field will be in this direction in that case. So I say Y higher potential minus lower potential, Y minus X divided by this resistor 2. What is this? I is equal to V by R. Higher potential, that is Y minus X, by resistor, that is this 2. Ravi, samajh aaya? Yeah, that's why this is a good question. When two junctions came, that's why it's confusing. Okay, let's move on to this one. Let's move on to this one. Let's kill this one now. Okay. I want you people to basically watch these lectures once again, so that everything is clear, and try to follow the questions from good books. Okay, on this one. हमने तुमको देखा जैसे. It states that algebraic sum of the potential differences around any closed loop of an electric circuit is nothing but a zero. Zero. The KVL statement is a conservation of energy. किसी को समझ नहीं आया, मुझे भी समझ नहीं आया. Okay? Let me just make you understand this one. Let me just give you the feel of this one. Exactly. Listen to me very carefully. See, nobody is going to give you the feel like I will give. Okay? Listen to me very carefully. If I say, for example, take this, if I am taking, for example, the circuit, okay? This is a closed circuit, okay? Forget about these definitions, okay? They will confuse you. If I say, for example, this is a closed circuit over here, fine. This is A, B, C, D, okay? A, D, C, B. I'm asking you to basically start from this one and you move something like this, okay? In a closed loop, understand? This is a closed loop. You're moving in a closed loop. This is a closed circuit. In a closed loop, you are moving over here, okay? Can you tell me how much is the change in potential over here? At this point, I would say the potential is exactly A, okay? VA, okay? Okay, listen to me very carefully. I would say the potential at this point exactly is A, VA. Fine. When you are moving in a closed loop, can you tell me what is the net potential exactly? What is the change in potential exactly? You'd say, sir, change in potential is nothing but that is VA minus VB exactly. Fine. VA minus VB. Means potential at one point minus potential at another point. If, for example, you are traveling from one point to another point, how much will be the potential? How much will be the change in potential or potential difference? You would say, sir, potential at this point minus potential at the next point. Okay, that is what we call the potential difference. That's how we have exactly defined over here. So can I say in this case, you are going from A, D, C, B, A once again. You are reaching the A once again. So potential at, you started from A. Understand? You reached A again. So can I say in this case, delta V is nothing but VA minus VA is nothing but 0. So delta V in this case is 0. If you are starting in a closed loop, okay? So we say basically net potential, net change in potential. Net change in potential in this case. There will be change in potential in different elements. Understand? That will have some value, but net potential will be exactly 0. This is the first thing, okay? I know. There is still some confusion in your mind. Let me just take that out of your mind, okay? Let me just take that confusion out of your mind. Okay, this is one example. Let me just take that confusion out of your mind. Listen to me very carefully. Previously we have studied one single thing. That is nothing but, if I say, for example, at this point, there is a unit charge. I would say this is the unit charge Q naught, okay? I'm taking this unit charge from this point A, where the potential is what? Point A, VA. The potential at this point is VA. I'm taking this unit charge, so I'll have to do the work done. I'm taking it to over here, to the next point. I understand? So I'll have to do the work done against the electrostatic force. If I say I'm placing the charge Q over here, fine. Pata hai na what is the potential difference. So listen to me very carefully. I am gonna give you the exact feeling. If I say, for example, at this point, I'm placing the charge, okay? Listen to me very carefully. If I say exactly, I'm placing the charge over here, okay? And there is this charge Q naught. I'm taking this charge Q naught and I'm bringing it to this point. Understand? This is the point A. I'm saying the potential at this point is basically VA. So what exactly I'm doing? I'm taking it from this point and I'm taking it to this point. Understand? At this potential, I'm saying the potential is basically VB. Understand? So can you tell me how much is the change in potential? You will say, sir, potential at this point minus potential at this point. That is change in potential. So delta V is nothing but VA minus VB exactly. VB exactly in that case. So what is that? You will say, sir, VA minus VB is nothing but this change. If you are taking this charge, unit charge from this point to this point, means you are doing some external work done against the electrostatic force of attraction. This is pushing this unit charge in the outward direction. So we'll have to do the external work done in order to take this charge from this point to this point. Understand? So we'll have to do this extra work done so that we'll take this charge from this point to this point. So now we say the amount of work done we need to basically do in bringing this charge from one point to another point, this unit charge, the amount of work done, this is what we call potential difference, change in potential. Potential difference is what? How do we define potential difference? The amount of work done in bringing this unit charge from one point to another point. Understand? Now I'm saying that you are taking this unit charge from this point to this point and getting back to over here in a closed loop. Now, could you please tell me what is the change in potential? You will say, sir, now the change in potential in that case will be, how much is the work done you did? Work done is what? External force multiplied by the displacement. So if you started from this point, you finally reached this point. Displacement, how much displacement you did? Nothing, 0. So can I say work done is 0? In that case, if work done is coming out to be 0, can I say this is coming out to be 0? In a closed loop, Dimag mein hit kiya? Is this clear to everybody? Is this example clear to everybody? Okay. We say net change in potential in this case. This is just an example. Okay. Afterwards, we'll have to basically see net change in potential. Come on, everybody in the live chat itself. Now listen to me. The algebraic sum of the potential differences around a closed loop in a closed circuit is nothing but 0. And in a closed loop, that is nothing but 0. The algebraic sum of a potential difference around a closed loop in a closed circuit, in an electric circuit, is basically 0. So now, if I start from this point and I'm, for example, moving like this, I'm basically reaching the point once again A. So there is potential difference. Change in potential is over here. Potential difference is here. Potential difference is here. Potential difference is here. Potential difference is here. Potential difference. But the net potential difference is exactly zero. Net change in potential is exactly zero. That is what I'm saying. This net delta V in a closed loop is equal to zero exactly. Fine. I'll just give you the more clear understanding of this one once again. Don't worry about that chill scenes. Okay, fine. Humne tumko dekha. That's great. So this is basically the scene over here. So if we try to write this mathematically, I'll just write it something like this: closed loop. Okay. Net potential. Understand that is plus minus V1. Plus minus V2 plus minus V3. Understand there might be change in potential in different elements, but net I'm talking about that will be 0, comma plus minus V4 up to plus minus Vn, it will be exactly equal to 0. It will be exactly equal to 0. Fine. Let me just give you one more feel of this one. See how exactly we're going to define in this one. Start from this point to this point exactly. A, B, D, C. Start from A in a closed loop. Okay. So what exactly you're gonna get? Can you tell me how much will be the potential change in potentials in this case? Okay. Can you tell me? In that case, how much is the change in potential? Understand, this law is basically based on the law of conservation of energy. Understand? Keep that thing in your mind. So basically we say in this case, can you tell me how much is the change in potential? You will say, sir, in this case, we are going from this point to this point. Current is in this direction. Can I say we are going from higher potential to lower potential? In case of resistor, 100%. In case of this resistance, we say higher potential to lower potential. How much will be the potential over there? How much will be this? Kya naam hai iska? How much will be the potential, exactly potential difference over there? If you go in this direction, according to the sign conventions, from this to this, we say V is equal to plus IR. From this to this, V is equal to plus IR. The direction of current is this one. Okay. See the direction of current. So it will be how much? You'll say, sir, that is nothing but plus I1. This is R1 in this case. Okay. So this is the potential difference in this one. We are basically going in A, B, C, D. That is, I'll just write it over here. That is nothing but A, B, C, D, A. C, D, A, exactly. Fine. So we say in this case, now you will say, sir, how this current over here is this I2. See, current over here is I2 because this is something like this. Understand? It may be connected to some other circuit over here, some other closed loop over here. That's why. Okay, so we say A, B, C, D, A. So this is I1, R1. So can I say this is I1, R1, and this will be plus. Change in potential over here. Difference will be exactly plus over here. Now in this case, can I just write plus I2, R2, plus I2, R2 exactly in this case, because this is direction of I2 over here. Now from negative to positive, we take this, what? This is gain in potential. We take gain in potential as negative and drop in potential as positive. This is in case of battery. Can I say this will be negative of E1 exactly over here, 100%. So over here, can I just say in this case, when you move from this one, this is the current of this, and this will be plus, this will be I3 into this R3 exactly. And in this case, we take negative. Understand? Because the direction of this is exactly negative in this case. So we are basically moving in this direction. The direction exactly over here is negative. This will be I4 and this will be R4. And in this case, this is from positive to negative over here. So that will be nothing but, because direction of current doesn't matter in the case of the battery. So we take this as positive. E2 is equal to 0. So net is basically 0. Net is basically 0. Net is basically 0. This is exactly the meaning. This is exactly the meaning. Fine. Just get all of these, and this is how we are supposed to solve the questions also. Let's go on to the question number 1. So first of all, I want you people to basically solve this question. Once you do this, once you solve this question, you will get the feel. You'll get the proper feel of this one. Okay. So can you just tell me in this case, use this simply in this circuit, okay? In this circuit, if I say, for example, start from this, okay? Start from something like this, okay? Because this is a positive terminal, go something like this. If I say, for example, current I is flowing in this one, okay? I current is flowing in this one. It will start from positive terminal and it will go exactly like this. So can I say in this case, if I use this KCL, apply KVL, apply, that is this KVL. We are supposed to find the current in this circuit. This is an easy circuit. You can find that with the Ohm's law also. Yes, 4 ampere. But we'll use the KVL. Afterwards, I'll tell you how to find this current in the complicated circuits. This is a simple one. So we say summation of this delta V in this case is basically 0. Now, can I say we are moving from this point to this point? Can you just tell me in this case, this will be IR plus IR. So this will be plus IR in this case. And this will be from negative to positive. This is gain in potential. So we take this as negative. So minus of how much this is E, that is 12 over here, is equal to 0. Can I just write it like that? So I plus IR, how much is this? That is 3I minus 12 is equal to exactly 0. So I will be nothing but 4 ampere. So in this case, so we got this one. Let's move on to this question. I want you people to find the current in this circuit, okay? As current will be I only. Why? Because this is, all the elements are connected in series, so current will be I only. Come on, tell me. Come on, all of you, I just want to know in this, in the live chat. हमने तुमको देखा. Jesse. Okay, so find the current in this circuit exactly. How we're gonna be basically solving this? I'm waiting for your answer. How much is it exactly? Come on, in the live chat itself. No, check it once again. Fine. Mark this exactly. This is A, B, C, D. Understand? Apply in this one exactly. Start from A. Start from A. Start from A. Okay? Start from this A exactly. Start from this A exactly. Somebody tell him who is your favorite cricket player. Okay? So start from this A. Come on. Tell me, I'm waiting for your answer only. Huh? Use this one only. Now apply KCL. Apply KVL in A, this closed loop, that is A, B, C, C, D, A once again in this closed loop. Fine. Closed circuit. So now, can you tell me? So now, first of all, what we're going to be doing exactly over here. So current is moving from like this. If I say, for example, this is I. So over here, this is I. Similarly, this is I exactly over here. This is in series. All the elements are connected in series. I don't know, bro. Srinivas, I don't know, bro. Thanks, man. Okay, so we say, in this case, it may be because of the camera. It may be because of the filters I put on the camera. So, A, B, C, D, A in this case. So can I just write in this case how much? This will be 3I. In this case, potential. So it will be positive. That is 3I. I'll just write it over here. I'll just write it over here. So it will be nothing but this plus 3I exactly. Understand? V is equal to IR. Understand? How much is R? That is 3. 3 into I. 3I. And in this case, can I just write in this case, it will be nothing but from negative to this positive. Okay. So this is gain in potential. We take gain in potential at that is negative. So that is nothing but 30 minus 30. And again, this is once again drop in potential. So we take this as positive. This from this point to this point. So this will be positive 2I. And in this case, this is gain in drop in potential from positive to negative. So it will be minus 15. What else? Over here, this will be plus I. And over here, this is drop in potential. Understand? So gain in potential, we take, this is negative, this is positive. We take gain in potential as negative. Okay, so we take this as negative. That is nothing but 20. And this will be exactly over here. This will be exactly over here. This is 4, exactly 4, I exactly, this is plus. And in this case, this is plus 10 is equal to 0. Everybody got this equation only? Come on. Everybody got this equation only? Check with this equation. Fine. All of you. If you got this equation, then this is the correct. Okay. So from here, you can definitely add this one. 3 plus 2 plus 1 plus 4. It will be 10. Yeah, this will be 10. I is equal to how much? This will be 50 minus 50 plus 25 minus 50 minus 50. This has to be 15. So this is this is positive. Okay, so this will be plus 15, so it will be exactly over here. That is nothing but 25. You check, this is coming out to be the correct one. So in this case, can I say I will be nothing but that is 2.5 ampere. Come on, check this. And I want you people to basically go for this one. Solve this. Find the current in each wire only, applying only Kirchhoff's voltage law. Understand? You're supposed to find the current in this one. You assume that current in this one, for example, is I1. In this one, this is I2. And consider this is I1 plus I2 because they are meeting over here. Fine. So you find in this one, you apply the KVL in this loop. You apply the KVL in this loop. Understand? There will be two equations. So the first equation and the second equation. Solve both of these equations. You will get I1. You will get I2 in this case. Okay. I want basically all of you to solve this and do let me know what is the answer of this question. I want you people to basically solve this question and do let me know the answer of this one in the live chat itself. Not in the live chat, in the comments. In the comments itself. Okay. Fine. Okay. So this was all about it. Thank you so much, ladies and gentlemen. इसमें plus 20 आना था ना? नहीं, इसको फिर से check करो. Thank you, ladies and gentlemen, boys and girls. So you can definitely follow me on Unacademy. This is my username, Yawar Manzoor. Hit the follow button as soon as possible. Okay. And apart from this YouTube platform, we teach on Unacademy's own platform. Okay. Over there, country's top educators are basically teaching you for sure. Okay. If you take this plus subscription, if you want to learn from those country's top educators, you need to basically take this plus subscription. Okay. If you take this plus subscription, you'll be getting live classes every single day, weekly tests, structured courses, unlimited access. Exactly. No, there is no special. Special class was in the morning, and tomorrow also it will be in the morning at 9 o'clock. If you can join, then join me. 9 a.m. Okay. It will be the PYQs, previous year questions, JEE mains of Newton's laws of motion, NLM. Understand? So in this one, you will be getting structured courses, unlimited access. Structured courses are those courses which have been designed by the country's top educators. You can definitely go for these courses in order to boost your rank in your upcoming JEE. Okay. And this unlimited access is nothing but you can watch anybody's lecture any damn time. That comes under this unlimited access only. And this iconic subscription is what? This iconic subscription is nothing but you'll be getting all the benefits you get in plus in this iconic subscription and some of the extra benefits as well, like personal guidance, test analysis, experts guidelines, study material, study planners. Okay, these are all the benefits that you're gonna get in this one. Online classes are there. What live classes you are basically asking me? Live classes. You're asking me about the live classes. So if you take this Iconic subscription, you'll be getting personal guidance. That's personal mentorship. Okay. Okay, fine. So, and in this Iconic subscription, you'll be getting the test analysis. Once you are done with your test, afterwards you'll have to analyze your scores, in what portion you are lagging in what portion you need to work more. That's done in this test analysis only. And this is what we call the personal guidance. And this is the experts guidelines, okay? Experts guidelines is without the tips, tricks of the different experts, it's nearly impossible to crack the JEE advanced exam. So that's why this is mandatory. Study material that will be sent to your doorstep for sure. Next thing is, you can take this plus subscription for 3 months, for 6 months, 12 months, 18 months, and 24 months. Even EMI options are available as well. If you take this, you don't have to pay the entire amount at once. You can basically pay it every single month, okay? So that is what we call this. And you can use my code Yawar in order to get the maximum possible discount. Use this code Yawar to get the maximum possible discount for sure, okay? You can take this Iconic subscription for 12 months, you can take it for 18 months, you can take it for 24 months, okay? By using this code, you can definitely get the maximum possible discount. This code, use this code only. Understand? Next thing is, these are the batches which we have launched recently, like started yesterday itself, from yesterday itself, 22, 22, 22, 29, okay? So these are the batches in which countries' top educators are definitely teaching you for sure. You can check it out from the Unacademy itself, because countries' top educators who have got 20 to 30 years of experience, they teach you inside Unacademy only. Understand? Yes, bye. And you can use my code in order to get this maximum possible discount. This is the great opportunity. You need to grab it as soon as possible. Understand? Like, for 24 months, this is before price hike, this is after price hike. You can definitely go for this one, okay? This will end anytime. So go for this one. And mega combo is IIT JEE plus CBSE. This is the mega combo. If you take this for plus subscription for 12 months, you'll be getting 15% plus 10% off. If you take it for 24 months, you'll be getting 20% plus 10% off by using my code Yawar only. Understand? Use Yawar to get this maximum possible discount. Even you can save up to 20,000 rupees. So go for this one as soon as possible, okay? The next thing is, I want you people to basically go for this biggest scholarship test. That's Unacademy Combat. This is a mega combat. Understand? So biggest scholarship test for IIT JEE aspirants. Even if you get the rank from 1 to 3, you'll be getting 100% of scholarship. If you get the rank from 4 to 10, you'll be getting 75% of scholarship. Even you can win the scholarship up to 4 crore plus rupees. So grab it as soon as possible. Don't wait. Understand? See, if you people are looking for learning free on Unacademy, this is the best way. This is the best solution, okay? So go for this. The link is in the description below. Join this. This is a test. It will be on 26th of September, 11 a.m. You just have to give the test. Use my code. It will ask for when you basically enroll, YAWAR. Okay. So this is completely for free. You don't have to pay anything. Just give the scholarship test. Give it a try. Okay. Next thing is, we have this beautiful feature on Unacademy, that's Ask a Doubt. If you have any sort of doubt, you can definitely post it on Unacademy. You'll get the solution within no time. Even you can ask the unlimited number of doubts. You can ask the doubt any damn time. You'll get the high quality video solutions, that too in English as well as in Hindi language. You'll receive the exact match for the questions for sure, okay? And how you can exactly ask this doubt, there's a doubts and solutions option. Click a picture, upload it on Unacademy over there. Make sure that picture should not be blurred. It should be very clear. And you make sure you need to crop that particular doubt. It's not like you'll send 5 or 10 doubts in just 1 second, in just one picture. No, you can only send one doubt at once. Once you'll get the solution of that, afterwards you can send the next one. So this is Ask a Doubt over here session. So this is like this one. And the next thing is, these are do's and don'ts that you need to basically follow in order to, when you basically go for this doubts and solutions. Thank you so much, ladies and gentlemen. It was really nice interacting with you. See you guys very soon. Like this video, subscribe to this channel, JEE English Unacademy. Hit the bell notification because that's mandatory. Whenever we come live, you will get the update. Like this, share this. Thank you so much. Take care. Bye-bye.